Good morning, everyone. It's officially 9:30, so we'll start our webinar. Today's webinar, Eyes in the Sky, the Drone Revolution in Engineering, is presented by one of our senior project managers, Joseph Tible. Joe is also one of our reserve specialists, and he has experience with our engineering services, reserve studies, transition studies, structural inspections, and facade inspections. As a part of the FAA Part 107 certified drone pilot, he conducts frequent drone inspections for communities, high-rise buildings, parking garages, and he leverages UAV technology to improve accuracy, safety, and efficiency. So Joe will give the presentation, and then if you have any questions, please put them in the chat. We'll go over them at the end, and if you want to jump in even and ask a question, please feel free to do so. I've put my email address in the chat, so you can email me after the presentation to receive your CEU credits.
Okay, thanks, Jen. Yes, as she said, my name is Joe Tible. I'm a senior project manager with Kipcon. I've been with Kipcon for 10 years now, and I've actually been a drone pilot now for 8 years, starting in 2018. So today, for the webinar, we're going to be talking about drone uses, services, and applications that can be found using drones. So the topics today, we're going to be covering drones themselves, kind of just going over a brief description over what they are. We'll go over the FAA regulations that exist, the different types of inspections that drones can be used for community associations, the uses and benefits of the drones, restrictions or limitations that may apply to the drones. And then I'll go through basically an example process of, what, we as an engineering firm would go through when setting up one of these types of drone inspections. And then I'll have a couple of, example photos of some other situations we've used drones for. And then after that, we'll get into questions. To start off with, we will start talking about what are drones. So they are UAVs, which is unmanned aerial vehicles. As the name implies, they are aerial vehicles that do not have a manned component in terms of, there's no pilot actually sitting in the aerial vehicle. So there's different types of drones, multi-rotor, fixed wing, single rotor, and hybrid VTOL, which is basically vertical takeoff and landing. The ones that you'll typically see are motor multi-rotor drones. These are, the standard drones that you kind of see everywhere nowadays. These are the commercial grade ones that you'll see everywhere. Fixed wings, those are typically, more of like the military grade ones, more of those high-end ones that because they're constantly moving, that's why they're fixed wing. The multi-rotor have the benefit of just being able to hover. Single rotor, it's almost like a helicopter. So there's a wide plethora of drones out there in the markets, from small to large drones. For the small drones, these typically, start off with the toy drones that you'll get at Best Buy or, Target or things like that. These are just entertainment toys. They're very cheap. They're hard to fly because they don't really have any processing components in them or whatever. But there are also some small entry-level drones, such as like the DJI Mini. These are, a nice blend between personal and commercial use. These are typically stabler than the toy drones, but they have a lower battery life than the, average drones that you'll see nowadays. And typically, these types of drones don't need to be registered with the FAA due to their weight. For the FAA, they require that any drones that weigh more than 0.55 pounds or 250 grams get registered, just because that's their basically designation for drones that may cause, more damage or issues if something were to go wrong. So those drones typically have to get registered. But for these smaller ones, that's why they're good for entry level personal use because they don't have as many restrictions in terms of having it registered, and they're pretty easy to fly for the as they're smaller. Medium-sized drones, these are either entry-level or professional grade drones. These are, like I said, the typical ones that you'll see nowadays. If an engineer comes out to your site or if someone else is using the drones, these are typically the types of ones that you'll see. They're typically more stable than the smaller drones. They typically have a longer battery life. Anywhere, nowadays, I think you're getting up to like 40 minutes maybe with battery life, but I would still say typically is around like 25, 30 minutes for each battery for each flight. And for these medium-sized drones, now that they're reaching over that 0.55 limit, they have to be registered with the FAA. And these drones typically are moderately cost. They come between like one to like two and a half, $3,000. So in that kind of mid-range area. And then there are also specialized drones. Some drones you can replace the camera itself, like they physically can be removed, and you can install like your own thermographic camera. Some drones come with their own built-in thermographic camera. Some also, have enhanced cameras on them, that may do 4K quality. And also there are some drones that have technically two cameras on them. One to allow the pilot to just, with a fixed camera on it that the pilot uses to fly the drone. And then a second, basically a second pilot would be just controlling the camera itself. So you'll see those kind of more in, marketing type things, things where you want the camera to focus on certain things while the drone is flying around. And then after that, there's large drones. These are typically just commercial drones. These are the most stable. A lot of these drones will have more than four rotors just because of their size or what they are meant to be doing. So, there are some drones now that are used as power washing drones where they'll attach a power washer hose to the edge of the drone and they'll use that to, clean the edges of buildings. There's some that carry packages, all the Amazon drones and things like that. Because they're larger, they have more power. They can lift things better, but typically their battery lives actually end up being around the same as the medium-sized drones, where you get around 40 to an hour uh, uh, for these drones. And then of course there's the military drones, which are the largest and most technologically advanced. So. Now that we're done talking about drones, we'll talk about the FAA, which is the Federal Aviation Administration, who is in charge of drones. So drones first technically kind of became a thing with self-propelled vehicles after World War II, where people started experimenting with unmanned aircraft. It wasn't until 2006 that the first airworthiness certificate was issued for a drone for use in the U.S. And then it wasn't until 2016 that a venue was actually created to kind of regulate drone pilots and what they can and can't do. And this is when the Part 107 rules were finalized and released. And I'll explain that in a little bit, but the Part 107 is basically one of the license required to be taken by the FAA in order to fly drones commercially. So then, after a year, there had been 80,000 registered Part 107 pilots. In another year, 100,000 registered 107 pilots, and the number's just been growing ever since then. And then one other just information that came out recently at the end of 2025, the FAA actually banned all new foreign-made UAV from entering the U.S. market. They don't rescind any authorizations or registration credibility for any of the drones prior to 2025, but any new foreign made drones were basically barred from entering the U.S. market. This includes DJI, which was typically the largest buy and fly makers of drones. So those were drones that you could literally buy, make sure the batteries are charged, and you'd be able to fly it right out of the box. Um, uh, that's just a thing that has recently just become uh, part of the FAA. So for the FAA, there are two types of tests that you can take because the FAA requires all drone pilots to provide proof of passage of an aeronautical knowledge and safety test. So these are the Trust or the Part 107. So the Trust is the recreational UAS safety test. This is the more recent test that was introduced in 2021. This is just for recreational flyers. It's a free test. You just go onto their website and complete this test. You can take it as many times as you want until you pass. This is just meant to get recreational flyers more accustomed with what some basic aeronautical knowledge and safety knowledge is, just to ensure that when you're flying, you're being a safe flyer. But like I said, back in 2016, the Part 107 license test was introduced. This is for commercial flyers. It's required for any commercial work or, for businesses. And it's a paid test that you would go to take. And then if you pass, you get your license. If you fail, you can pay to take the test again. But like I said, this is required for commercial flyers, and this is what we at Kipcon have in order to do our drone inspection work. So for the flight rules, basically, Trust and Part 107 kind of have the same rules. Part 107 just allows more exemptions and more possibilities. But in general, for the Trust, it's flying only for recreational purposes. The drone must be flown within visual line of sight. You have to give way to other aircraft, follow all the FAA guidelines regarding airspace, and operate in the drone in a manner that doesn't endanger others. Part 107 is the same, except you're allowed to fly for commercial work, and you can receive waivers for flight in controlled airspaces or for beyond visual line of sight. So, if you have a multi-acre location that you were trying to drone, before you would have to kind of go with the drone, make sure you keep within its visual line of sight, which might extend the flight time or the length of the inspection. If you have a Part 107 license, you can apply for a waiver to allow beyond visual line of sight flying. So then just to kind of quickly go over the airspaces, as this is, relative information in terms of the drone pilot himself and where, your community might be located. There's basically six types of airspaces. Class A is typically 18,000 feet and above. That's for commercial flights. That's where all the, commercial flights, if you're flying down to Florida, they're flying in Class A airspace. It's all regulated through the air traffic control system. Class B is the airspaces that are used around the busiest airports. So these are like international airports, Newark, JFK, LaGuardia. These are typically 10,000 feet and above. MSL, which is mean sea level. They do elevation readings for airspaces from mean sea level. Class C is basically around airports with control towers and radar approach control. So these are kind of more your standard airports, like Atlantic City, Albany, Lehigh Valley, larger airports that still have, towers and radar. Class D airports are basically, the more local regional airports like Teterboro, Lancaster, Westchester County. These typically only have a control tower and don't have any radar approach. And those are usually, lower elevations because, they're usually typically smaller personal planes. And then Class E is basically, if it's not A, B, C, or D, and it's typically between 14,000 to 18,000, that gray space between where A starts up on the higher end of it and wherever the bottom of, the top of the Class A, B, C, or D airspaces are. Class E kind of fills that general gap in between everything else. So if it's not A, B, C, or D, it's going to be E. And then Class G is uncontrolled airspace, and this is typically, around 400 feet down to surface level. And this is the airspace that drones are basically allowed to fly in, without receiving a waiver. And so here's just kind of a quick visualization of the airspaces. As you get higher up, the airspace expands outwards. So, as you can see from the drone, we typically only are allowed, we legally are only allowed to fly up to 400 feet above ground level. If there are structures that are taller than 400 feet, we do have the leniency to fly with the kind of, as long as I believe as long as you're not 50 feet over the height of the building, you're still legally allowed to fly it, even if it is over 400 feet. So that covers like high rises that may be taller than 400 feet. We still can fly the drone to inspect that building. As basically the requirement for the 400 feet is just to ensure that the drone isn't interrupting, airspace for other planes. But since we're near a building anyway, the other aircraft won't be flying that close. So that's why we have a bit more leniency with tall buildings. So, like I said, Class B major airports, Class C typical airports, Class D is the smaller minor airports. Class E is just kind of if it's not included in one of those other classes, then it's basically Class E, and then Class G is kind of that uncontrolled airspace. So then when we're going to go do the flight, we have to look at airspace maps. I just wanted to give you a quick look at what an airspace map might look like. These are the analog models, the physical printout ones that you would see. There's a lot of information thrown on here. A lot of the information isn't used by drone pilots. It's more for aviation, but I just wanted everyone to be able to see, kind of how complex kind of the airspaces can be. There's various numbers around here. They basically are just kind of showing you, as I showed in this last image, how they expand outward as they get higher up. Basically saying, from surface, this is one flight zone. Then as you get further out, it expands outwards and higher up until you get to the very edge. And then that's the edge of this Class B airspace. Dashed is Class D, I believe. And these ones are Class C. But the types of maps that we'll use in our services are typically digital maps. They're available online, and these kind of are more geared towards drone flights. So these basically show you where the airport zones are, and the numbers that are kind of shown in there are basically the height restrictions on drones in that area. So, near Newark, nothing is really allowed to be flown right near the airport. If you're in one of the sides where, it's not directly over one of the runway flight paths, they give you a bit more leniency so you can fly up to, 100, 200 feet. Typically, so these areas kind of give you the idea of the height you can fly and where you can fly around near airports. Now, if you have a Part 107 license, you'll be able to apply for waivers to raise the height of these restrictions. So, you can say we're flying like over here near Newark. We might be able to get a waiver to fly, up to 100 feet instead of the 0 that's shown here if we have a Part 107 and we, send that into the FAA. So, about airspace authorization and waivers. What if the site is located near an airport? You can apply to the FAA for two different types of waivers. There's the regulatory waiver and the low altitude authorization and notification capability system, which is the LAANC system. So a regulatory waiver is an official document that is submitted to the FAA. This is for changes in the flight from the core rules of, the Part 107 license. So this is if you want to fly over groups of people, like if you were over a stadium, if you wanted to fly from a moving vehicle, from like a car or from a boat or something along those lines. If you wanted to fly at night, or if you wanted to fly over the 400 feet above ground level, you would submit one of these waivers. Typically, it would take about 90 days for the FAA to review it and get approval back to you. So this needs to be done well in advance, and it requires a Part 107, so that way they know all the rules and regulations regarding flying a drone. The LANC system is much more simple. It's performed through FAA-approved third-party apps. The DJI apps themselves, I believe, have an inclusion in that system. and it allows for flights at or below 400 feet in controlled airspace. So this would be, you go into one of these sites, you say, I'm going to be flying in this area near the airport. I'll probably be flying around like 100 feet. You would submit it, and you'd get just a notification back saying, your request was sent in, and they'll either approve it or, deny it right then and there. So then, now that we've looked at the airspace and get that, how do you actually fly the drone? Just a quick overview of flying the drones. One stick will control the elevation and the rotation of the drone. The other stick will basically move it in a plane, so it'll move forward or sideways. They're typically controlled by remotes. Some remotes have built-in screens. Others, you can actually plug your phone in, and it'll give you a live feed from the camera. Also, third-party apps can be used to fly the drones, not necessarily straight from the manufacturer. And then you can fly the drones manually, or you can do an automated flight. So for manual flights, this is flown by the pilot using the sticks. You can take videos and photos and video manually. You have more control of the drone since you're determining where it's going, and you can adjust photo settings as you're taking, either photos or videos. Increase the quality. You can actually do a lot of like the manual adjustments for cameras, like shutter stop and aperture and all those kinds of things. And typically manual is, less planning required. You're just going out there and flying. Automated flights are typically done by, like another app or another service. Some examples are Drone Deploy, Drone Link. These, you basically set out a set perimeter or a flight plan that you want to do. This will get uploaded to the drone, which then uses GPS coordinates to basically fly the flight path. If and it can also set up automatic photo taking too as well. So it can fly around a whole community, take photos every certain amount of the distance, and then afterwards it'll stitch all those photos together so you have a nice large overview of the area you were trying to photo, and then you can also zoom in since the photos themselves have a lot of detail. And then these apps also use the metadata from the photos, which can be used to provide elevation readings or 3D mappings of certain buildings or locations. These typically have to be planned beforehand. They can be set up on the site visit, but it eats into your time out there. Typically, these are planned beforehand and set up beforehand. So now I'm just going to go basically through various use cases for drones in our industry. These are just an example of some of the inspections that we here at Kipcon have used drones for, or things that might be useful for community associations to use drones for from an engineering side. So these are facade inspections, roofing inspections, balcony inspections, thermographic inspections, and site inspections. And then also the drones can be used for marking materials. So I'm just going to kind of go through each type of inspection, basically what they're used for, conditions that we've experienced with them, and then why you may want to use a drone for these types of inspections. So for facade inspections, these are the evaluations of building envelopes or exteriors. Typically, these are manual flights, though they can be automated. More and more programs are, getting more advanced and starting including automated flights for facades. These are the easier way, using the drone is an easier way to inspect the entire facade, especially for taller buildings, because you'll be able to document the entire facade, having the drone, fly up and fly down, move over constantly, going through, so that way it captures every angle of the facade. This is typically cheaper than having a scaffold or suspended scaffolding drop because you don't have to have a contractor set those things up. And typically those are just along one line. If you're doing an inspection with a drone, you can view the building all the way around without needing to set up multiple drops. And provides more detailed information than just ground observations, since you're at most maybe 20-30 feet from the building, as opposed to ground level 120 feet below, and trying to look through binoculars or a zoom on a camera lens. So, with the facade inspections, the drones will be able to capture, if there's any brick deterioration. We've been able to capture a failed mortar, step cracks, spalling, missing bricks. You can observe, if there's any missing sealant or failed sealant around windows. The condition of lintels. If we you can determine, observe if there's any, sagging of the lintels, or if there, is any visible rust that might be observable. Staining or efflorescence areas where water might be getting into the building or out of the building. A failed exterior finish, missing weeps. Basically, the drone can help capture a lot of these, issues with facades. And reasons you might want to use a drone for a facade inspection is, Jersey City has a facade inspection requirement by law where a facade inspection has to get done every 5 years. So a drone can help out with that type of scenario because you'll be able to evaluate more of the building. If you want to, just get a sense of your whole building's condition, you can use the drone because it can evaluate all the sides, give you a sense of, prioritization in terms of, oh, we were thinking of doing maybe a couple windows or something like that. Can you just, let us know which ones might be the worst ones? Drone would be able to easily go around and at least prioritize and identify them since it's looking at all of them. If there's a leak getting into a unit or something like that, and you're trying to look at it from the outside, drone can pinpoint that specific location that you think it might be coming from, and perform observations without having to need like scaffolding, a ladder, any of those things. And then if you're doing a remediation project, the drone can also be useful to, observe the working condition if you don't want to interrupt the workers while they're on the scaffolding, or if you want to view previous completed work. You don't need to have the contractor come back out there. You can have the drone basically observe it. So then I just have some example conditions that were observed from our drone inspections when looking at the exterior of the buildings. On the sixth floor, we were able to see, deterioration at the base of the windows, missing sealants at the bottom of the sill. On the fourth floor, we were able to easily see a step crack that was forming in some brick. High up on the ninth floor, there was a small deterioration in some eaves coating that we were able to catch. Same for some stucco coating. Um, when at another building on the fifth floor, we were able to observe just some, minor corner cracking that wasn't really visible from ground level, but once you get the drone up closer, you're able to see it. And then also same, on the fifth floor, we were able to see that some lintels had started to sag at this facade, which might not be readily visible from ground level. But we were able to, come out there, take a look at it, and observe that the lintels were sagging. So then the next type of inspection that we typically do are roof inspections. So these, the drone can be used to evaluate the building roofs. These can be done with either automated flying or manual. For larger sites, automated is beneficial just because it's going to capture all the roofs from directly above. You can then use that information to then fly it manually at the concern locations and get more in-depth observations at those roofs. It's safer and cheaper than a normal inspection. So to do it with a drone, it would be safer and cheaper because you're not walking on these sloped roofs. You don't have to worry about getting up there, and if anyone's ever walked on a roof before, it can be pretty unsettling when it's sloped. So, drone provides safety and ease, and it'll be quicker because you don't have to, climb up on ladders, get up onto the roof, walk around the whole thing. You'll have it all documented already from the drone. And typically these photos are taken either directly from above or angles. So that way you can evaluate, flashings, if any of the shingles are lifted, anything like that. And the benefit also is you can evaluate a large community with multiple roofs, such as this community down here, with a one-day drone flight as opposed to trying to get up on only a percentage of roofs or, trying to get onto every single one. That would take forever, but you can evaluate with a drone in a day. So, conditions that the drones will be able to observe, failing shingles, either ones that are deteriorated, missing, or loose. If they're missing kickout flashings, if there's any improper flashings where, the roofs might meet a sidewall or something like that, or flashings around those cases. Any at bridge caps, if they don't have sealants installed at the exposed nails on the top, the drone will be able to catch those. We've caught that for a lot of transition studies. If there's any staining on any of the shingles, you can use the roof inspection to also kind of prioritize which roofs you might want to replace first or later. And also for, flat roofs or sections where there's low slope, you might also be able to you'd be able to observe any like standing water that was there or anything like that. Like I said, if you wanted a roof inspection, you could use the roof inspection for prioritization of roofs. If there's a transition study going on, you can use, the drone to evaluate a large quantity of roofs, like I said before. Um, if there's water concerns, with the roof, it also would be able to, observe the gutters if there's a buildup there. Are they properly connected, fastened? Or if there's specific locations that are leaking, you can send the drone up to the roof and observe if maybe there's some issues in the roof at those locations where water infiltration might be occurring. So some example drone photos from when we were inspecting roofs. Here we had observed the gutter pulling away from the fascia. It wasn't necessarily obvious from below, but when you get above, it's clearly obvious, very observable. Areas where shingles had fallen off, where you wouldn't be able to see unless you got up onto the roof. Also, some like vent cap covers falling off. With the drone, we can get right even with the roof. So, we'd be able to see if there were bulging shingles. Like from this image, if we were just looking straight up and down, this might not be evident. But because we're taking multiple angle shots with the drone, you're able to see these other types of conditions that, might not be able to easily see, just from ground level. And, you're easily able to point out missing shingles or issues that are observed on the roof. So another type of inspection are balcony inspections. We use the drone a lot for structural integrity inspections that have balconies. It's typically a manual flight. It's easier than trying to get out onto the balconies by going through unit owners' units. It doesn't require any access if we're using the drone. So it's a cheaper in that sense because we're also able to observe every balcony as opposed to trying to get out onto every balcony, which might take longer. We only might be able to get onto it personally, on a percentage of balconies, but with a drone, we're actually able to evaluate every single balcony. The drones can also be angled, up or down, so that they can capture the underside of the balconies and capture that as well from a lot closer than on ground level. And like I said, it allows you to evaluate basically all of the balconies in a building or community as opposed to just a percentage of them. So, with these drones, we've been able to observe, failing coatings, deteriorated concrete for the balconies, whether that be, cracks, spalling, looser and proper railing connections. There were some locations where we were able to observe that some of the screws in some locations were starting to loosen up a bit, and we're able to call that out before it became an issue. Or that sealant was missing around some locations where the railings are going through the coating and it might cause water infiltration later. And you get a nice documentation of all that with the drone usage at the balconies. So, it's, the reason you might want to use a drone for balcony inspection is you want, the overall conditions of all the balconies, or you want a prioritization list of, which balconies should we, repair first, or should we do coatings on first? So that way you don't have to just assume that you have to do everything. Like I said, for structural integrity, for structural evaluations of the balconies, we can use these to see, if there's any major signs of deterioration for all of them without having to get onto them. Or if there's, specific concerns at balconies, you can use the drone to get to them without having to get through the units. Um, So these are just some example photos of some balconies. With a drone, you're able to see the face of the balconies. For this one, there was some exposed rebar, some spalling at the railing posts. For this one, we had some spalling right near the corner and near the railing posts as well. Um, Typically, embedded railings in concrete balconies always seems to be an issue if you're pulling anything from any of these images. But like I said, we're also able to see the underside of the balconies from up close, so you're not just looking at it from ground level. You get nice, clear views of that and can see where there may be peeling coatings or issues from underneath, and those can all then be addressed before they become major concerns. Another type of inspection that can be done with drones is thermographic inspections. Like I said, there are some drones that come with a thermal camera and some that you can attach one. These are typically either manual or automatic flight. It can be done similar to the roof inspections where you can automate it over the whole community and then focus in on specific locations. Typically, these should be performed in the morning or the evening. This is kind of indicative of any thermo inspection that you're trying to, if you're trying to find water infiltration or possible air leaks. That's just because, in the morning or the evening, the temperatures are just either rising or start falling. So the surface of these buildings or locations, it heats up quicker than the actual. If there's water underneath it or air behind it, that air or water isn't going to heat up as quickly as the surface will in the morning, and then in the evening the surface is going to cool down faster than the water will, just because of the properties of the water. So then you'll see a temperature difference at those locations, and that's how you can kind of use the thermographic imaging to determine if there might be water infiltration or an issue at those locations. And the nice thing is, since it's on a drone, you can get a lot closer to higher up locations or other areas that you might not be able to reach when you're just doing a handheld thermographic inspection. So like I said, you're looking for water infiltration, failed coatings where, water might be getting behind it, improper flashing, allowing air into a space behind a facade. The reason you might want to use the drone is, like I said, hard to reach areas. You want to document a large number of buildings. The drone just speeds up that process and allows that thermographic inspection to be done, closer than just handheld. So then I also have some examples where we had a thermographic drone inspection done for the roof and facades of some buildings. In this one, you can see the elevated temperature readings along the fascia of this balcony, indicating that the water might be getting in there. Also near the edge of the building, there's also an elevated reading. Same for the roofs. Maybe there's an air gap underneath the shingles, or this is venting more than it should. Around windows and another fascia. So the thermographic is a great tool to isolate locations if you're unsure of where water might be used infiltrating in or something like that. You can have the drone fly over, find those specific areas, and then you could do a hands-on, more invasive testing to determine if there actually is. And then another inspection for site inspections, or overall whole community inspections. These are typically more automated flights as opposed to manual, just due to the size. And like I said, a lot of these programs with the automated flights stitch the images together. So you can get, not only marketing imaging of your entire community, but then you can also zoom in and get details. And you can also use these to evaluate, landscaping, grading, locations, make sure things are installed where they should be. And like I said, from the drone photos, you can pull, it pulls the metadata from it, so that way you can actually get grading elevation readings from the drone photos themselves. So, typical conditions that we use the drones for is for checking landscaping, grading, sidewalks and roadways, and stormwater management, facilities where they're located, ensuring that they're all, properly installed those ways. So, particularly for transition studies, these site inspections with the drone are incredibly useful. Um, they can all, for site inspections, like I said, for grading, if you have grading issues that you're concerned about, the drone can go over and get a sense of what the grading might be at those locations. If there's specific locations you want to take a look at, you can get a nice overall overhead view of it at different angles, that help to evaluate in those situations. And so, some example conditions from site inspections, this is just an example of an elevation reading.
I'm actually listening to a Kipcon webinar
Oh, sorry.
today.
And so these are elevation readings.
Yeah, I need to have a CEU credit.
So the blue, shows the lower elevations. You can see how the buildings are raised up to shed the water away from them. Here's a storm water management inlet, so you can see why it's a lower area there, so that way you can pool the water. With the site images, you also get a good sense of, where there might be poor turf germination around a community, if the vegetation isn't holding up. We've used the drones to observe, cracks in the base course of asphalt roads that we've, flown around, because you can get a pretty remarkable detail from these images. Even if they're flying 200 feet above the ground, you can still zoom in pretty well and see, relatively small cracks in the roadways and the sidewalks. And then, this can also be used for construction in progress. If the community is being built, you're able to, get overview photos of the community, and you can get multiple of them, so you get almost a progress of the work going on. So with some of the automated flying programs, such as Drone Deploy, there are additional benefits. So when they create the stitched image of the community, the program allows you to overlay PDF drawings over the drone images. So, you can use these to determine slope and grading readings, grading readings. So you can put the grading drawings on overlaid over the drone images, use the elevation readings in the program, and then you can kind of compare the drawings to the elevation readings, directly on the screen, which is, an example here. You have the sharp, elevation drop for the basin itself, and then once you get to the edge, it evens out, and you can kind of see that with the color references. So this is a good way just to ensure that that they are following along with the drawings, which is for transition studies, or evaluations of your communities, it can be extremely useful. And so then here are just some examples of, overlaying these PDFs, for landscaping. You can use these to just ensure that all the landscaping is installed in, relatively the correct locations and in the correct numbers. With these, you can easily see, the trees are generally installed where they should be. These plantings moved up a little bit, but they're all generally installed where they should be. Same along with with this photo over here, just showing, all the landscaping along the side and how it generally conforms to it. Um, Here is just, the photo of the location without the PDF overlaid on it, and then the location with the PDF overlaid on it. So that way you can, change the opacity of the PDF, go back and forth. So these are excellent engineering tools for use at communities on sites, particularly. For stormwater plans, you can use these to ensure that the catch basins are installed, where they're shown on the, design drawings. Here we have a lawn inlet and the three catch basins, and then an outlet into one of the actual basins. And then when you overlay the actual PDF, it shows that, that they're all properly, installed where they are. So this is a great way to verify this type of information. Just another example, showing, there's a lawn inlet, two catch basins, and then it dumps into the basin. When we overlay it, we can, verify that all those items are installed where they should be and conform to the drawings. And then also with Drone Deploy, you can do comparison. If you do multiple drone flights of a location, you basically can get a slider, and now I'm easily able to compare before and after a top course was installed around the community. So if I look at beforehand and see where they may be marked for repairs or there was some damage, I can then pull it, move it over, look at the after, and see if there, any issues with those types of locations. So it's a great tool for comparing between multiple flights. And then, like I said, drones are also extremely useful for marketing. It's more than just an engineer's tool. Typically, when I go out to a site that I'm going to be droning, I try and take a nice overall photo of either the community or the building I'm at, more from an angle as opposed to head over. Just so that way, when we provide the photos, we can provide them with, another image that they may not have been able to get before. Now they can use it for marketing. Um, so that's also just a wonderful use of drones in general. And like I said, when I typically go out to a site, I try and include at least a couple just overview shots of the community for that community's use. So just to kind of recap the uses and benefits of the drones, if for ongoing construction, you're able to document all the things going on, allows you real-time comparison to the design drawings. Like I said, you can overlay where the stormwater management systems items are going to be, and if you're if having drone inspection during the construction, then it allows real-time comparison to ensure that everything's, following the drawings. It's cheaper and easier than typical inspections because, you're not requiring scaffolding, you're not requiring, another contractor to be there to provide access to the engineer. It's safer than getting up onto the roofs or walking around those. And in general, it takes less time than, if an engineer had to walk around a community and perform it visually. The drone itself will be flying around, so it typically will take less time than if you were trying to do it without the drone. It provides easy documentation. You have all of these photos now, so if you're doing manually on your own without the drone, you might only take photos of the areas that you're looking at that you have concerns with or things like that. With the drone, you're getting the whole community. So even if something arises up later and it's like, oh, was there an issue with this location back then or something, then you have all these images that you can go through. And also, if you do multiple flights, it's all typically stored in the same place. Makes it easy to kind of go back and review all these things. And with the drones, you get valuable information for your community, and also a bunch of good photos that you can use as well. Now, and then for the restrictions and limitations, there are, flight restrictions that you got to take into consideration when you're flying a drone. Are there the airspaces around? Are there airports nearby? Are there any temporary closings due to no-fly zones or, major events? The weather is another restricting, component when flying a drone. If there's rain, unless the drone is IP rated, which, is the rating to basically see how well it performs with water. If it's not IP rated, you can't fly in the rain. Most drones typically aren't IP rated, or the drones that are, but the batteries themselves aren't. But rain is a major factor to not flying the drone. Wind is another one. And then lighting can also be an issue. Typically you want to, it helps to have photos taken when there is cloud cover over, because then you don't get those harsh shadows. So like an overcast kind of day is usually the best lighting for these types of site drone inspections. Just because then you don't have to worry about the shadows getting in the way. It makes it easier to observe the images from the drone. But that all kind of depends on what you're looking at. Sometimes you might want more lighting just to get a better view of it. And then another restriction is time. Thermo typically can only be done in the morning or evening. So the flights have to be planned around that. Maybe there's only a couple days where an area gets closed for a no-fly zone, like it has happened occasionally, like around these areas, that has to be taken into account. For limitations, you're worried about vegetation, trees, how close they are to the building, narrow spaces, things that might make it difficult to fly, or the pilot might not be comfortable flying. And then also the battery life. There's only a certain amount of batteries that will be brought with the drone. The battery only lasts a certain amount of time, so that just has to be taken into consideration when the pilot is planning the flight. So that kind of goes over the general gist of drones in our industry, what their uses are, benefits from using them for the communities, and then I just kind of wanted to go over an example process of if you contracted Kipcon to perform a drone inspection of a site, what would be the steps that we would go through. So we would first check the airspace, around the site. Is there any airports? Are there no-fly zones? Any time requirements? Things like that. So for this example, the site that we're using it as the example, not located near any of the airports, so we don't have to worry about any airspace restrictions in terms of letting the FAA know. After that, then we would plan the flight. So, this is an example of the community. We would set up the limits of the area, and basically it would provide us, the amount of time it would fly. We would adjust the height. Would we need to plan for multiple flights, depending on if, the community is located in one area, or whether it's, kind of two areas with maybe something in between that you don't want to fly over because it's not your property. When you're setting up the map, it'll, like I said, tell you kind of how a guesstimate of how long the flight will take. So, you got to balance the height of because the higher you fly, the less time it's going to take, since you can get more of the site in those photos. So you have to balance, time with detail when you're setting up the flight, because you want to get as close as possible, to get as much detail as possible, but you also don't want to use up all your time, because if we're going on a larger site and we're flying 50 feet above, it might take almost 4 hours to flight the whole site. But if we fly at 150 feet, maybe it only takes 45 minutes instead, or an hour. So it's always balancing that detail with time and what you're trying to get out of the inspection. Then then we would coordinate the site visit. We would have to monitor the weather to ensure there's no rain or heavy wind, set up the date and time, and then we would perform the flight there. And then, for this type example site inspection, we would have the automated flight fly over the site, and then we would supplement also with manual photos of, while we're looking at things, areas of concern or anything along those nature. And then after that, the photos would get uploaded into the program. You can upload documents. So, you upload all the drone photos. The app that, we use would stitch it all together. We can then upload photos of, like, say, the retaining wall, and compare that to the existing, just to see how it, compares. And then you would perform the evaluation of the community. So that's, kind of the step-by-step process, generally for, like an example site inspection. And so now, as we're nearing the end, I just wanted to kind of provide some photos from some other drone inspections, necessarily don't fall into those other categories, but are just a good example of, the capabilities that drones might provide use for communities. So for this, one building, they were checking on the solar panel arrays. So instead of, having to get up onto the building, they just wanted to get a drone out there real quick. We were able to go and evaluate the solar panels in terms of, just general condition assessment. For this, we did a soffit and fascia inspection at the edge of a high rise, where we used the thermographic imaging to identify some problem locations, along with visual photos of the locations as well, and then use that for our evaluation in a report. We've used them for window evaluations. So, there was a community where we had gone around and used the drone to document all of the windows in the community for any signs of, failing sealant, the framing around them, the lintels, the sills, all of that. So, and they were looking for a prioritization of the windows. So that was just a way for them to get a sense of, how many windows need to get replaced in the near future versus, later down the line. Um, this was for a location where there was a specific water infiltration issue at the building. And, we were able to observe, some poor flashing on the sides, crack going through the concrete. And actually, there was a gap that wasn't sealed between this penetration and along that crack line. So the drone was able to, just fly up there real quick and pinpoint the issue of where the water infiltration might be coming from. This was at the exterior of a high rise. We were evaluating the columns on the exterior. You might not be able to see this even from the roof because it's on the outside corner. So the drone was able to quickly get up there and, determine or observe the areas of deterioration. Um, we've used drones for fire escape evaluations where we've had the drone fly around to each fire escape in a community and document their condition above and below. So that way, we can see if there was any areas of concerns in terms of, here there was an opening at one of the handrail connections that should have been closed up. Or we were able to observe, areas of rust on the fire escape, so that way they could plan which ones needed to be recoded by the end of the year and which ones would last a bit longer. We did a parapet, a concrete parapet inspection at the exterior of this building. Some of these areas are very difficult to see because you don't want to stick your head over the edge of a small parapet on, a high-rise building. So with this, we're able to determine, where areas of additional repairs might be needed. And then from this is just from another high rise, basically from one of their balconies high up. From here with the drone, we were able to observe that two of the tiles, are starting to come loose. So we were able to point that out before it became an unsafe condition. So basically, in conclusion, there's a lot of wonderful uses for drones nowadays in community associations and in engineering in general. There's a lot of, data and information that can be pulled from them, and is a very useful tool in terms of, aiding engineers and community associations in these evaluations by saving, time, money, manpower, all this, and it provides, great amount of documentation and information available. So I wanted to thank you all for listening to our webinar regarding drones. And at this time, I will open it up to any questions that people may have. I see we probably have, do we have
We have one in the chat from Jane.
okay.
Jane asks, has Kipcon been utilizing drone services when working on a new reserve study for a community to check any component's integrity? Or is this something that you need to request? What is the typical cost to have a drone inspection?
So for reserve studies, typically we don't include the drone. For just basic studies in terms of that. They can be used to evaluate those the components. For larger communities, they could be used to evaluate just the general condition of the roofs. I would say for around it would probably in general between 1 to 2,000 for adding in drone inspection to the probably not that much. That's just like if a drone inspection was getting done of like a roof, it would probably be around that much. It all depends on the conditions and the situation and what's going on around the area. But they can be that would be something I would need to talk to our reserve specialist leader, main project, reserve study head of the program. If that would be something that can be included. just because we do a lot of reserve studies and we don't have a lot of drone pilots and the time to have every single one be included. But I do believe that that could be something that can be requested if we feel that it would add something to the reserve study. Because, for a high-rise building, we're going to be walking on the roofs, we're going to be looking at the exterior, and it's for the reserve study, it's more of a budgetary tool. So, if it's different than if you were doing like a full evaluation of these components. But it is something that, if you're trying to get kind of more detail for things, probably can be talked about and requested. Any other questions?
That was the only one in the chat. And then Ron's question, there will be a recording of the webinar. It'll be posted to Kipcon's YouTube channel later. And after today's presentation, I will send an email with a copy of the slides. And you can respond to that email to receive CEU credits. If you have any questions that you think of after, you can also feel free to send those my way. And Joe is copied on the email, so he'll be able to give his expertise.
Yes, yes. So yeah, if no one has any more questions, I want to thank you all for coming out, for allowing me to expound on drones in our budgeting industry. And yes, I thank you so much, and hope you all have a great day.
All right. Thank you, everyone. Thank you, Joe.